Hello everyone, welcome to the ninth tutorial class on digital communication, which will be presented by me, Dr. Sudip Mandal. So coming to the content of this presentation, we will first discuss time signal extraction property for the line coding. Then we'll elaborate the working principle of regenerative repeater, which is a major advantage of digital communication system over analog communication system. Then after that, we will discuss inter-symbol interference, which is commonly known as the ISI effect. That is nothing but distortion due to the pulse spreading in the digital communication system. And after that, we'll also discuss the Nyquist criteria to minimize the ISI. That means Nyquist criteria for zero ISI. Okay. So coming to the first topic, that is the timing signal extraction for the line coding technique. So, in the earlier classes, we have already discussed different line coding technique like on-off coding, polar, bipolar, polar RZ, polar NRZ, Manchester differential, etc., etc. So, all these type of line coding techniques are basically used for efficient transmission of digital signal through the communication channel, and each of the line coding technique has its own several advantage and disadvantage also. Time signal extraction is another important property for the line coding technique. So what is the necessity to extract timing signal? That means what is the sampling period that has been used during the line coding, that is need to be known at the receiver section for the correct detection of the incoming signal. Okay, so in digital communication system, basically we use regularly spaced interval along a digital transmission line to detect the incoming signal. Okay, and it is also required to regenerate new clean pulse for the repeater. So the operation of the repeater will be discussed in the next slide. So before that, just for our own interest, we may conclude that timing signal extraction is an important property for line coding technique. Okay, there are basically we are emphasized on self synchronization. That means we want to extract timing signal from the line coding technique itself. Okay, so timing information is necessary for the bit synchronization. So, uh, suppose we consider polar RZ line coding. Okay, so yeah, it has been observed that if we use a full wave rectifier and we send a polar RZ signal through it, then it can produce clock signal of frequency that is the same as the signal frequency. Okay, so let's see here. You can see that for bit pattern 110010, the corresponding polar RZ, polar that means 1 is represented by half pulse with plus half pulse with positive pulse, and 0 is represented by half with negative pulse, rectangular pulse. Okay, so this is the polar RZ. As the value is returned to 0, that means we call it as RZ. Okay, so this is basically polar RZ type. Now, if we send it through a full wave rectifier, you can see that the corresponding output will be like this, and which is nothing but a clock signal. That means polar RZ has self synchronization property. That means we can extract timing information from the polar RZ itself. Okay, and this clock signal or timing information is very important to us for the correct detection or correct decision making at the receiver end. That means if we don't know the which is the what is the clock frequency, then we cannot decide at which value, but at which instant is 1 and which instance is 0. Okay, so timing information is very crucial or very important to us. So very few line coding technique has this property. So polar RZ is an example of such kind of technique. Now coming to the very important topic, that is the regenerative repeater. Okay, so what is the function of regenerative repeater? So whenever we send a digital signal through a communication channel, it is digital signal get attenuated and distorted. Okay, attenuated and distorted due to the several kind of noise, and attenuation coming to the due to the propagation through the communication channel. That means if we send suppose 5 volt signal through a channel, then obviously due to that several losses, this voltage level will be attenuated, and moreover due to that the several nonlinear characteristic and others noise, the shape of the pulse will be changed. That means the pulse will be distorted. So um, regenerative repeater, the name suggests, that means repeat. That means we can generate a fresh train of pulse after some distance and retransmit the fresh pulses through the channel again. Okay, so as the digital communication system, we need to detect only the few voltage level, like plus a by 2 or plus a or minus a or 0 volt, like this. So we can easily detect this voltage level, either there is either positive voltage level or negative voltage level or 0, like this. But this is not possible in case of analog communication system, where the voltage level can take any finite, any continuous value. Okay, so here digital communication system detection is very easy. That's why you can use regenerative repeater. Okay, so using this regenerative repeater, it is possible to achieve the property. That means we can easily regenerate a fresh pulses, okay, that contains same information as the earlier one. Okay, so basically a regenerative repeater performs three functions. First of all, it can reshape the incoming pulses by means of equalizer. Now the equalizer function of the equalizer will be discussed in the next classes. So it has been written that reshaping of incoming cell. That means we already told that due to the distortion, the shape of the pulse has been changed. So by using the equalizer, we can remove the distortion. Now, second function is the extraction of the timing information. It is always necessary for the um, correct regeneration of the pulses. Okay, so different process we can extract the timing information. One process already has been discussed, that is the self synchronization, and third point is the making symbol detection decision based on the pulse sample. That means we can detect what is the incoming voltage level. Okay, now this is the basic block diagram of regenerative repeater. We can say, you can see that this was the incoming signal, that means, and this was the transmission medium. So in the medium the noise had been incorporated, and due to this noises and the losses associated with the medium, the output signal is attenuated and distorted also. Okay, now this signal now this signal is distorted and noisy one. Sorry, so first part of the regenerative repeater is the preamplifier and equalizer. So here you can see that After this, the signal has been amplified and distorted portion has been removed by means of equalizer. Then the signal output signal has been go to the timing extraction portion, where timing information or clock signal has been extracted. Now using this timing information, we can sample and take decision what is the voltage level, what is the corresponding voltage level at the different instances. Then after that, depending on the decision, we can regenerate fresh pulses and transmit through the communication channel again. Okay. So here, now let's discuss the working principle of the different blocks in details. First of all, the preamplifier, as you already told. So the main function of the preamplifier is the to amplify the incoming signal. That means due to the propagation along the communication channel, the attenuation has been compensated by means of preamplifier. Second part is the equalizer. Okay, so basically, as you already told, the channel distortion has been removed by using the equalizer, and the operation of the equalizer will be discussed in the next classes. And it is interesting to note that the property of equalizer should have the frequency should have a frequency characteristic that is inverse to the medium. Okay, so that the distortion that is created due to the channel that has been inversed. Okay, so next one is the timing extraction. As you already told, the timing extraction is a very important part so that we can take correct decision. Okay, so there are basically three processes but through which we can extract the timing information. First one is the master slave timing source. That means here transmitter and receiver slave to a master timing source. Okay, that means there are completely different timing source, and the corresponding frequency has been already known to both transmitter and receiver end, and from there we can use the generated clock signal. Okay, so it is basically the master slave timing source, and it is costly and suitable for a large amount of data. Okay, now in the second process is like transmit a separate synchronizing signal. That means you can send a separate signal that has been called as the pilot clock. Okay, so that can be used for the corresponding um, extraction of the timing information without using the incoming line coded data. Okay, so like the pilot carrier, we can use the pilot clock for the digital communication system. Okay, now the self synchronization is already discussed, that by using some line coding technique like polar rz, we can easily extract the timing information from it. Okay, so these are the three process through which we can extract the timing extraction. Okay, so coming to the fourth part, that is the sampler and decision. Now using the extracted timing information, we can take decision for the incoming voltage level. That means at which instance what is the corresponding voltage level, and depending on that we can take the we can detect the corresponding out voltage level. Now next is the regenerator. Basically regenerator is nothing but a buffer or amplifier that restore the original voltage level depending on the output of the sampler and decision section. So suppose the incoming voltage level, it has been detected at 3 volt. So obviously as you already know that 3 volt, that means if we know that maximum voltage level is 5 volt, so obviously the function of this uh, regenerator section is there to amplify the corresponding 3 volt voltage level to the 5 volt voltage level and send the corresponding output to the to the communication channel again. Okay, so these are the basic. So by using this process we can easily retransmit a fresh pulses of line coded data through the channel. So this is the major advantage of digital communication system and this is not possible for analog communication system, as the value of the corresponding signal can take continuous or infinite number of values. Okay, so next we're coming to the uh, inter-symbol interference, that is called as ISI effect. Okay, so in digital communication, ISI is a form of distortion in which one symbol interfere with subsequent symbol, and this is an unwanted phenomenon. Okay, here you can see that for if we use like on off signaling, where one is represented by a rectangular pulse like this. Now, due to the several reason, this rectangular pulse has been spreaded. Okay, and this is and you can see that, and the width of the rectangular pulse spread beyond its time period. Okay, so this is the basically practical width, whereas this one is the actual width of the rectangular pulse, but due to the several reason, this pulse has been spreaded beyond its period. Okay, so due to this reason, it is possible that uh, two consecutive pulses can overlap with each other, and for this purpose the shape of the pulse has been changed. That means there has been some kind of distortion, and this distortion is known as the inter-symbol interference or ISI effect. And for this purpose, the decision making at the sampling instances is very difficult. That means the communication system become less reliable for this inter-symbol interference distortion. Here you can see that this one is the change in shape. That means this one is the distortion portion, distorted part. Okay, now let's see what is the reason behind it. Okay, so most of the communication channel are basically band limited and improper in real life. Okay, that means they are non-ideal channel. For ideal channel, the bandwidth is infinite. That means all frequency can pass through the corresponding channel. Now, in real life, all the communication channel are non-ideal. That means most of the spectrum of a pulse can pass through it, but certain amount of spectrum is suppressed whenever the signal is passing through a communication channel. Okay, due to its non-linear characteristic. Okay, here normally in case of line coding technique we use rectangular pulse, and we all know that the Fourier transform of rectangular pulse is the sinc function, which has basically the theoretical bandwidth is infinite. So in that scenario, the portion of the rectangular sinc function has been suppressed. Okay, now this type of channels are called dispersive channel. So all the real life channels are dispersive in nature. That means very few amount of spectrum cannot pass through the corresponding channel, and due to this reason, the corresponding output from the channel is not in shape as the rectangular pulse, because its frequency characteristic has been changed due to the dispersive nature of communication channel. Okay, so when a time limited symbol or rectangular pulse pass through a improper channel, rectangular pulse will spread in time domain. Okay, and this phenomenon is known as pulse spreading. Okay, now due to this pulse spreading, if we consider the earlier fact, show here you can see that rectangular pulse has been spreaded beyond its limit. Okay, so due to this pulse spreading, two consecutive pulse can overlap at the sampling instant, and the same of the pulse is changed or distorted. This is nothing but the ISI effect or inter-symbol interference, where two consecutive symbols interfere with each other due to spreading of the pulses. Another important parameter or fact for the ISI effect is also multipath propagation, where if we consider ear to ear communication, where we receive signal from the different path. So in that case, overlapping can happen, and we also observed ISI effect in that case. However, due to ISI, decision making is difficult at sampling instant, and which may lead to the erroneous result. Here you can see that for 101, this is the line codant. If we consider the on off type line coding technique, so basically this one is the 101, and after passing through the communication channel, improper communication channel, the corresponding pulse is spread beyond its limit. Here you can see that in this region the pulse should be 0, but here you can see that due to the pulse spreading, they overlap with each other and you get a corresponding voltage level at this point. So obviously this one is the erroneous point, and here you can see that uh, this one this portion or this portion or this point, this one are called the decision making instant. So at that point, suppose at this point the value should be 0, okay, but here you can see that we get a finite voltage level. So here we can told you can conclude that ISI has been occurred at this decision making instance. Okay, now let's see how can we remove this ISI effect, because we need to remove the ISI effect so that we can clearly detect corresponding voltage level at sampling instances. Okay, now the condition for 0 ISI, the basic concept for the condition for 0 ISI or to achieve the 0 ISI, that that the pulse amplitude can be detected correctly despite of pulse spreading if there is no overlapping or 0 ISI at decision making instance. Okay, so the point is that means this one is the decision making instant, this one is the decision making instant. If there is no overlapping, if there is no overlapping at the decision making instances, then we do not need to bother about the others value in between them, because we take decision at this sampling instance at this point. Suppose this one is a t1 second, this one is a 2 second. So at 2 seconds, or what is the corresponding value of the signal? So that is the crucial point. If at this point somehow we can achieve able to achieve 0 ISI at this only sampling instant, then we don't need to bother for others point. Okay, so the basic concept or the main concept for 0 ISI is that there should be no overlapping or 0 ISI at decision making instances. Okay, now scientist Nyquist proposed a condition for 0 ISI. To eliminate 0 ISI, to eliminate ISI, scientist Nyquist proposed a solution which is known as the Nyquist criteria for 0 ISI. Okay, so here scientist Nyquist achieve 0 ISI by choosing a pulse shape. That means normally we use the rectangular pulse for line coding. Okay, but here we can use the different pulse shape instead, where we can get non-zero amplitude at center t equal to 0, and 0 amplitude at t equal to plus minus ntb, where n equal to 1, 2, 3, and tb is the sampling period. Okay, so here you can see that for this pulse we define such that we get a fine non-zero value at t equal to 0 second, but we get the but at the adjacent sampling instant it will become 0. And moreover, we are not interested at the others point except 0 and plus minus ntb value. That is the decision making instant. So by equation mathematically you can express pt like this, that at t equal to 0 the value will be 1, at t equal to plus minus ntb, that is at sampling instant, value will be 0, and others point we are not interested. So this criteria or this condition should be followed by the corresponding pulses. Now one of the such pulse can be represented by sync function. If we observe the sync function, like here you can see that this is one of the sync function, and you can see that at t equal to 0 second the value is 1, and corresponding this one is the sampling instant, this one is the sampling instant, this one is the sampling instant, this one is the okay. So at all these points the corresponding value is 0, but we are not bothered between 0 and 1 by rb. Now you can see that if we use this sync function for two consecutive 1, we can see that there will be no overlapping. As suppose consider this. So for first sync function we get a corresponding value at 0 second, and but its value at tb second is 0. For the second pulse we get finite value of a another sync function, but you can see that as all the value of the other sync function is 0 at tb second, there is no overlapping at decision making instant, so we can get only corresponding value of this pulse. Okay, now similar thing is applicable for others pulse also. Okay, so obviously we can achieve 0 ISI by using sync function. Okay, now we know that for the sync function it has property that at t equal to 0 its value is 1 and others value plus minus ntb. Okay, where rb is the 1 by tb, that means frequency. So Fourier transform of the sync function is rectangular pulse, and we can express corresponding Fourier transform using these rectangular pulses. Okay, so you can observe the corresponding Fourier transform of this rectangular pulse is like this, and this is strictly band limited. Okay, you can see that it is strictly band limited. But if we use the rectangular pulse, the corresponding Fourier transform with the sync function, and whose theoretical bandwidth is infinite in nature. As this is the band limited, strictly band limited, that means it can it has less effect. It has less effect, or it has no effect in the pulse spreading, because pulse spreading mainly occur due to the band limited channel or improper characteristic of the channel. Okay, so if we use this type of function or this type of shape, we can easily achieve 0 ISI. Okay, now the problem is you can see that the the corresponding Fourier transform is a rectangular pulse, but in frequency domain in real life, such type of sharp decreasing transfer function is very difficult to achieve. You can see that. That means in real life, proper realization of sync function is very difficult. If we can achieve proper sync function in real life, then we can achieve strictly band limited. That means you can see that after zero point 0.5 rb the corresponding value falls suddenly. Okay, sharply falling or sharply decreasing. But in real life, the sharply decreasing frequency characteristic function is not practically feasible. Okay, so it is hardly possible to design a signal with sharply bandwidth signal like rectangular function. So in spite of it, you can use this gradually decreasing function whose frequency response is gradually decreasing. Okay, that means which is vestigial in nature. So we can use a vestigial spectrum where spectrum gradually decreasing, but it should maintain zero ISI. Now such type of signal are called raised cosine signal, and which can be expressed by using this equation: RB cos pi RB by 2 divided by 1 minus phi RB square t square multiplied by sinc pi RB2, where you can see that uh, its value, this one is the dotted are the raised cosine, and this one is the normal cosine. So you can use raised cosine signal also for this purpose. Okay, so coming to the conclusion, so what we have studied, we have studied the working principle of regenerative repeater, where we can easily regenerate a fresh pulse that can be used to transmit again through communication channel. After that, we have studied distortion uh, that has been associated with intersymbol interference. That means distortion that is created due to the pulse spreading between two consecutive symbols, and this is known as the ISI also. And after that, we also studied how can we remove this ISI. Okay, so by if we use sinc function or raise cosine function, so we can achieve zero ISI. Zero ISI means we need to achieve, or we need to focus only sampling instance only. We don't bother on the others point. So if there is no overlapping at the sampling instances, then we can achieve zero ISI. So by using sinc or raised cosine sinc function, we can achieve zero ISI. And this one also called as the Nyquist criteria for zero ISI. Okay, so that's all. In the next classes, we will discuss the equalizer, zero forcing equalizer. Okay, that can be used for the to remove the corresponding distortion or to remove the ISI. And we also studied how can we measure the ISI effect. Okay, using eye diagram. Okay, so that's all. So these are the references that we have been all used. Thank you. If you have any question, please post. Thank you.